All right, folks, here we go. So today we're working with section 7.4. 7.4 involves parallel lines and proportional parts. So reading through here, if a line is separated, if a line is parallel to one side of a triangle and intersects the other two sides in two distinct points, then it separates these sides into segments of proportional length. So again, here's our proportional symbols. So that means this over this is in proportion with this over this, and we put that there, cross multiply, and we can solve from there. This is the converse, which states that if they are in proportion, if you do have a proportion, then the sides are parallel. Next one, same concept here, and then that leads us into this slide right here. So RT is parallel to VU. So what you're going to do is you're going to set up the 3 over 8 equal to x over 12. And the next slide, you can see that's going to be solved for us. And then they ask you to find SU, but once you find x, that's the same as SU. So hopefully you cross multiplied and solved. You can see how we set that up. You get that answer is 4.5, which is the same as SU. Next one here, we have same idea, parallel lines. You can see that. So we're going to go 10.5 over 4, set that equal to x over 6, cross multiply. 10.5 times 6 equals 4 times x. 10.5 times 6 gives us 63 equals 4x. Divide both sides by 4. You output a final answer of D. Next slide here, converse. Same idea we already went through. Now we are going to try a problem to determine whether they are in proportion or not. So xy is 15, yz is 25, WA is 18, and AZ is 32. So you set up your proportion 18 over 32. Is that in proportion with 15 over 25? You can cross multiply to solve or just kind of reduce. If I take out a 2 here, I get 9/16. Take out a 5 here, I get 3 over 5. Those two are not in proportion. So no, your answer is they are not parallel, even though it looks like it. This one's a little trickier, but the same idea. You want that concept, though, that it's a like 2-to-1 ratio. And with the 2-to-1 ratio, you come out to be 13x or 36x equals 36x. So it's kind of a weird way to show you what we're trying to get to, but ultimately, yes, these sides are in proportion. This one right here, a mid-segment of a triangle is parallel to one side of the triangle. Its length is 1/2 that of the side. So right here, you output, here we have your parallel lines. So JK is 1/2 of FG. And also notice with the mid-segment, this is equal to this, and this is equal to this. So let's apply that here. This one I have solved also, but what I want you to take a look at here is I would actually want you to set it up correctly first. I did my first step, so I'd go x plus 5 equals 1/2 of the 9x minus 4, and then I would get into the next phase of solving. Find that x is 2, and then you plug it in. I found that x is the MP is 7, and then I did CB just to show you that the other one's double. This slide right here is just a concept where if this is 5, you double this to be 10 because we have DE and EF are mid segments. If this big side is 18, half of that is 9. Just kind of working with that concept. Next one involves angles. Two parallel lines right here cut by a transversal. They want AFE, or alternate interiors, so they're both 87. Next slide here, same concept. If this is 15, half of that is 7.5. If this is 8, double that to get 16. Next slide here, we have the alternate interiors. Alternate interiors where they want us to find AFD, so this is the same as this. Both going to be 122